So in section 1 of module 1, we're going to look at some different types of equations and different types of graphs of those equations that we'll encounter in this first part of our course. A lot of these you should have seen in previous coursework, other ones may be new. The first one is what's called the identity equation. And the identity function is just a function where x and y are always the same. So it's our standard linear equation. So y equals x. Or, of course, if you want to do the function notation, we could say f of x equals x. So on this graph, all the points on this graph, x and y will be the same. So if I do that, what I find is on my graph, I just get a straight line like this. The second type of basic equation we're going to look at is the squaring function. The squaring function will, of course, look like y equal x squared. So all the y values are the square of their x value, or f of x equal x squared. Now, just like the identity functions all look the same, for squaring functions, they all look the same as well. And as you should remember from Algebra 2, all things with the highest exponent of 2 look like parabolas. So some kind of U shape like this. Or it could be one that faces upside down like this. But the general squaring function is just kind of centered at the origin. It just kind of goes like this. So all these are squaring functions. The next function we'll look at is the cubing function. Now the cubing function is when you're going to take the y value be the cube of the x value. So we write that as y equals x cubed, or f of x equals x cubed. So all the y values are just the cube of their x values. And so the graph you see like this, we actually give it a name. We call it a cubic curve or an S curve. So it comes up this way and kind of goes this way. So that's a cubic curve. The next one we'll look at is a square root function. Now a square root function is when the y value is going to be the square root of the x value. So y equals square root of x. Or this can be written as f of x equals square root of x. Now as you should know from algebra, square roots can only be positive. If you do a negative square, you get imaginary numbers. And our graphs are all real number graphs. So a square root function starts at 0 and kind of goes up like this. And then, of course, any other function that looks in that same general shape could also be a square root function. The next one we're going to look at is what's called the reciprocal function. Now, reciprocals in math are essentially when two numbers are flipped. So you could think of 1/2 and 2 over 1 as reciprocal numbers. So the function for the reciprocal function, the y value is the flip of the x value. So we write it 1 over x. Or in function notation, we can write it as f of x equals 1 over x. Now this is one of our most interesting graphs, as the one problem with this graph, if you think of the x value of 0, 1 over 0 is undefined. So we can't have 0 as one of our values. So what the graph ended up looking like is it's a curve here, and it's a curve here. And at 0, where you can't have 0, we have this kind of imaginary dividing line, which sometimes we'll write as a dashed line. This is called an asymptote. So this has a vertical asymptote. Vertical because the line goes up and down versus left and right. Has a vertical asymptote at x equals 0. So that's going to kind of divide this graph into two parts. Our next function relationship will look like is the exponential. Exponential is when you have a variable in the exponent. So we have y equals b to the x. So b is just some number, so it could be a number 2 to the x. Or in function notation, it could be b to the x. Now, an exponential function, essentially you are doubling or halving or multiplying the value by the same number every time. And these have a pretty distinct graph as well. They start out real flat and then they take off quite a bit. Okay, so they start real flat and then they'll take off very quickly. They could also do the opposite. They could come up from here and go down very quickly and then flatten out as well. Either of those are exponentials. The difference just is in the base, in the b, what the b number is. If b is bigger than 1, it goes up. If b is less than 1, it goes down. And we'll look at those in future chapters. The next one we'll look at is what's called the logarithmic function. From algebra, you should have examined a little bit about exponential and logarithmic functions. So the logarithmic function we'll look at is just y equal to the log of x, or f of x equals log of x. So this is what's called the common log, which means it has a base of 10, but any log really has a very similar graph. So a log graph is our second graph we're going to see with a vertical asymptote. A normal log has a vertical asymptote at 0, and that can be moved. It can be moved left or right. And then the graph goes up pretty quickly and then slowly grows from there. So our next one is what we call the absolute value graph. The absolute value graph, which we would write as y equals absolute value of x, or f of x equals absolute value of x, always looks like a V. The y value is always positive because no matter what you plug in an absolute value, it's positive, so it looks like a V like this. Now other absolute values could go the other way. It could look something like this. But any graph that looks like a V is going to be one of our absolute value graphs. The next one we're going to look at is what's called the logistic family. Logistic growth is a very slow growth, and the equation for logistic growth is y equals 1 over 1 plus b to the negative x. And again, b could be any number, kind of like the exponential. B could be 2 or 1/2 or 3 or whatever you want. And in function notation, it could be the same thing, 1 over 1 plus b to the negative x. Logistical growth is a very slow growth. It's very flat, but unlike the exponential, it kind of takes off, but then it slows down again. So it looks something like that. You see a lot of logistical growth in statistics and probability. So you'll see how the probability will approach a certain number, so that's very indicative of logistic growth. The last one we're going to look at is what's called a periodic function. Periodic functions, we're just going to write it in here. So periodic functions is when the graph will repeat itself. So the most famous periodic function is the sine wave. So we say y equals sine x, or f of x equals sine x. And other ones you've looked for in algebra, cosine, tangent, they are also periodic functions. And what you'll see with a periodic function, it's basically the same thing over and over again. So sine wave just kind of goes up and down in one direction, up and down the same way in the other direction. So that is a periodic function. So this is just a quick look at some of our basic functions we're going to look at this year. So if you have questions about any of these, please let me know.